Assalamu alaikum. We will start in this class to do some examples and questions about IV bolus one compartment model. We are still talking about IV bolus, single dose, one compartment, and linear kinetic, which is first order kinetic. Okay, which is, this is our model, and we are talking about IV bolus. And as we are talking about linear kinetics, so we have first order elimination at constant. Okay. In the exam, you will have an equation sheet in which all the equations that you have, you'll have them summarized in one sheet to make it easier for you to go back for the equations if you forgot anything. And I will show you an example on that before the exam. Okay, so let's start with the calculations. Question 1 to 3 are very easy questions, but we will do them to show you how easy you can have questions, or how easy the requirement of some questions, but you need to be as accurate as you can. Okay, so let's start with this question. What is the concentration of the drug? So we are asking about concentration at 0 time to 4 hours after a dose. So this would be 500 milligram. Known pharmacokinetic parameters are apparent volume distribution, which is equal to 30 liter, and elimination rate constant, which is equal to 0.2 over -1. So the question is asking you about this. What is the concentration at different time points? You can use whatever the equation that you want from the model equations that we have. And all of them should give you the same final answer, because it's the same equation with different versions of it. Okay, so we need to have CP at time 0, okay, which is your initial concentration, which will be over VD, and we have both of them, milligram over 30 liter. And be sure that you are using the units, the proper units in your calculation, and just make sure that it's the same unit you have in the options of your question. Okay, this will be equal to 16.67 milligram per liter. Okay, the second one is 2 hours. We need CP 2 hours. Okay, which will be equal, first of all, you know that CP at certain time equals CP naught E minus K multiplied with the time. So I will use this here. Okay, CP naught, we already had it in unit of milligram per liter, multiplied to E minus 0.2, and it's in hour -1, so the time should be in the unit of hour, which already we have it in hours. Okay, and this would be equal to 11.2 milligram per liter. Okay, the last one, which is 4 hours, the same thing, but you are changing the time that you are substituting. And this would be equal to 7.5 milligram per liter. Okay, we are just changing the time that we are asking about. Okay, okay, then Let's go with the second question. If CB at time 2 hours, so we have 2 hours concentration equals to 5.3 milligram per liter. CB at 6 hours equals to 3.2 milligram per liter after a dose given that is equal to 350 milligram, okay, which is the same unit that you have here, so we are fine. What are the values of K, VD, CB naught, and clearance, total clearance, okay? So those kind of main parameters that we usually define, so you should be able to calculate them as quick as you can to make it easier for you in the exam to go through other requirements or other questions or part of questions, okay? We have 2 points. Because we have 2 points, it's the same if we want to sketch it. It's the same as having this and this. And we have here 2, 5.3, and we have here 6, 3.2. So the same thing. I may ask you the same thing or the same question in this way. And for sure, as we're talking about rectilinear or concentration without any changing, it would be for a single dose IV bolus like this, okay? The same thing you would have it F concentration versus time, similar graph, and we will have 2, 5.3, and we will have 6, 3.2, okay? The same numbers because it's semilog, so the graph only is changing, not the numbers that we are graphing, but it will show a linear profile, okay? So I may ask you the question as a rectilinear profile as this, or in a semilog profile as this, or just giving you the information in the question, okay? So let's start with K. What we need to do to define or determine K, okay? So to determine K, which is the first order rate constant, we know that if we have the equation, we can determine it from linear regression, but we don't have the equation. So what you need to do, you need either, because we have it here in, as concentration rate transformed, you need to know this, which you already know it, that is equal to minus K over 2.303 if we are on a log transformed equation or graph, okay? And this would be log y2 minus log y1 over t2 minus t1. Or let's just keep it in x2 minus x1, okay? Which would be equal to log cb2 minus log cb1 over t2 minus t1, which would be equal to minus k over 2.303, okay? If you substitute your numbers, you will have log 3.2 minus log 5.3 over 6 minus 2 minus k over 2.303, okay? And from here, you can determine the requirement or the question or the parameter that I'm asking about. So K would be equal to 126 over minus 1. Okay, this is your first parameter. So this is done. Now we need to know VD, okay? How to determine VD, or you can just continue with CB node, for example, and clearance, okay? How you can determine CB node? CB node, we know that it's X node over VD. We have this, we need this, but we still don't have this, so you can't use this. So if you have, as we have two concentration in the question here, you can use any of them to determine CB node, because CB node is the same, okay? So let's start with, or let's use 2 hours equation. So CB 2 hours equals CB node E minus. We know that this is 2 hours. We already had this, which is 0.126 hour minus 1. CB node is the parameter that we need, or the value that we need, and we have this as 5.3 milligram per liter. So just play around with the equation, rearrange it to have CB node equals to 6.8 milligram per liter. So we finished this. You can directly now do a substitution here. If the CB node equals 6.8 milligram per liter and your dose is 350 milligram, same unit, we are fine, over VD, you can determine your VD, right, by rearranging the equation. Then VD will be equal to 5.13 liter, okay? Then you are done with this one. We still have the clearance, and we have so many ways to determine the clearance, but depending on the values that we have, then the clearance equals to K multiplied with VD. Then this will be multiplied, our minus 1, multiplied to 1.3 liter. Then this give us liter per hour as total clearance, okay? And by this, you finished everything that the question needs, okay? So let's see the third question. I'm asking it's the same kind of way, but I'm asking about different values. See, in this question, I'm asking about the dose required to achieve certain plasma concentration. So, sorry. Okay, so CB that is given at 6 hours equal to 3 milligram per milliliter, okay? And the dose is what is needed. What is the IV dose required to achieve a plasma concentration of 3 milligram per milliliter at 6 hours after the dose is administered? Knowing that the elimination rate constant, K, 0.26 over minus 1, and the volume distribution is 28 milliliter, okay? So as the volume is the same here, we are fine again, and we have concentration at certain time. We need to know the dose. Again, if you put the equation that you have at certain time equals CB node E minus K with time, okay? We have this, we have this, we don't have this, and we have this, okay? So we know, as we know that the CB node equals X node over VD, and we have this. By knowing that, you will be able to determine this, okay? So Let's go. CB at certain time equals 3 milligram per milliliter, which is equal to CB naught minus 0.26 multiplied to 6 hours, because it's shown. Let me remove this. Six hours. Okay, CB naught would be equal here. Do you the arrangement to define it and or to calculate it, and then you'll have this as your CB naught. Am I finished? No, because it's asking about X naught. So if CB naught is equal to X naught over VD, this is 14.3 milligram per milliliter, and this is X naught over the volume, which is 28 milliliter. Then I can define X, which is the needed value, then X naught equals to 399.7 milligram. Okay, and if it's in the question asking you about gram, you can just convert it to gram. Okay, this is the first 3 questions which are considered examples of assembly questions that you may have, and the main parameters or values that we usually ask about, or you need to do it as fast as you can to save time during